Hello everyone, once again welcome back to my channel. So in this video, we will be discussing about how JS works under the hood. So without further ado, let's get started. So this diagram may look confusing, like what are they and what each does. So don't worry, I'll explain you in detail. So the first component, or you can say the main component, is JS engine. It consists of heap and call stack. So it handles the code execution mainly. JS engine is a place where the code is run line by line synchronously. What synchronous means we'll wait for the code to finish before we move to the next line. But JS engine also needs web APIs and event queues to handle asynchronous tasks or a line of code that is asynchronous. Again, asynchronous means opposite of synchronous. It basically doesn't wait for the task to finish. It directly move to the next line, or you can say it runs tasks parallelly, asynchronous tasks parallelly. And this parallel running of tasks achieved through web APIs and event queues. Yeah, one final thing to explain is event loop. The red color loop which you are seeing on the screen, it's basically nothing. It's just a mechanism which checks event queues and call stack of JS engine. Means if the event is present in event queue and call stack is empty, it pushes the event from the event queue into the call stack. So this is how event loop works. It basically prioritize the events in the event queue and push into the call stack of JS engine. So there are two types of queues. First is microtask queue and second is callback queue. So both handle the callback written by different APIs differently. So if the microtask queue has some event and callback task has some event, then first the priority will be given to the microtask queue. Means microtask queue events will be executed first by JS engine, then it will move to callback queue task or event. So the microtask queue priority is higher than the callback queue. So I can give you the web APIs example which goes into the microtask queue and which goes into the callback queue. So set interval, set timeout, they both go in callback queue and promises will go into the microtask queue. So let me explain you with the example. If we execute this script, first the hello from promise will be printed, then hello from timeout will be printed. It's because promises will go into the microtask queue and set timeout will go into the callback queue. And we know the microtask queue has higher priority than callback queue. That's why promises will be executed first, then set timeout will be executed. So this is basically difference between these two types of queue. So at this point, you might got an idea what each component does in the diagram, which I showed you earlier. But you might have one confusion, which is like why I'm referring promises or set timeout as the API. Like I'm saying promises API or set timeout API or set interval API. So these are API because they are not a part of JS. Yes, you are right. They are not the part of the JS. They are built into the browser. But now you will say I'm able to run these set timeout or promises in my local system or in a browser JS compiler. It's because browser JS compiler is running on browser, so it is using the web APIs from the browser. And you know these set timeout or promises are built into browser only, so it's not going to throw any error. And if you talk about local system, so you might be using Node.js for running or executing the script. So that's the reason, because the Node.js behind the scene or internally uses libuv library, which makes this possible to execute the asynchronous task. So that's the reason you are seeing that it's running on your system or in browser compiler. So these are the definitions of what we have discussed so far. So you can have a look into it. Now let's consider this code snippet to understand the working. Firstly, JS engine creates a global execution context. When JS script is executed, then it allocates the memory to the variables and functions in our script. So in our case, you can see users and greet will be allocated memory, and user is given undefined and greet has function definition. So see, primitive data types like number, string, boolean, etc. are stored in stack memory, but dynamic data or non-primitive data types are kept into heap memory. In our case, user will be in stack and greet will be in heap. Once it's done, the execution context is pushed into the stack, call stack of JS engine. And you can see at line number 5, greet function is called. So separate execution context is created for that function, and again the memory allocation phase comes and memory is allocated, and but since in our function there is no variable and function, so no memory will be allocated. So again this context will be pushed into the call stack of JS engine, and after this the console will be printed, means console log will run, hello web app will be printed, and this context will function execution context will be destroyed or popped out from the call stack. And after that this global is also completed, so it will also be popped out. So this is how JS works under the hood. If you found this video helpful, please vote this up